Io is the most volcanic world in the solar system, a moon that continuously buries its own surface under fresh layers of molten rock. When the Voyager probes first reached the Jovian system, the instruments began recording data that contradicted the expected behavior of a small moon. Later, missions like Galileo flew through a dense torus of plasma surrounding the moon and recorded significant drops in the local magnetic field strength. These instruments measured a massive electrical current of 10 million amperes flowing through the vacuum between the moon and its host planet. This electrical connection is visible in Jupiter's upper atmosphere, where auroral footprints glow at the exact points where the moon's magnetic tubes make contact. These observations revealed that Io is far more than a satellite. It is a central component in an interplanetary circuit spanning hundreds of thousands of miles. Scientists were left with a massive technical question. How does a small, distant moon generate enough power to influence a gas giant? The answer lies here. Jupiter and Io operate as a single colossal electrodynamic machine. To understand the mechanics of this generator, we have to look at the orbital forces that melt the moon's interior. This machine is powered by orbital resonance. For every lap Ganymede completes around Jupiter, Europa completes 2, and Io completes exactly 4. This mathematical alignment creates a gravitational tug-of-war. The outer moons pull Io away, while Jupiter's massive gravity pulls it back, forcing the moon into a stretched elliptical orbit. As Io moves along this path, the planet's gravity physically bulges and compresses the crust. This constant flexing generates immense internal friction, melting solid rock into silicate magma. This energy escapes through hundreds of volcanic pits, blasting magma onto the surface at temperatures reaching 1350 degrees Celsius. While the magma reshapes the surface, it also releases massive plumes of sulfur dioxide gas, providing the raw material for the electrical circuit. These gases paint the landscape in yellow and red sulfur deposits and maintain a thin, patchy atmosphere that is essential for the next step of the interaction. Jupiter rotates once every 10 hours, dragging its massive magnetic field past the much slower Io. As the field lines sweep through Io's atmosphere, they collide with sulfur dioxide particles, stripping away a ton of matter every second. These newly ionized particles are heavy, dragging against Jupiter's magnetic field. This causes the field lines to bend and tangle as they move through the plasma wake. This drag forms 2 field-aligned tubes, known as Alphen wings, extending thousands of miles from Io to Jupiter's poles. These wings act as the high-voltage wires of the system, carrying the 10 million ampere current that completes the circuit between the planet and its moon. This circuit is fueled by the destruction of Io's own environment. Every second the system runs, the moon bleeds its atmosphere into the surrounding plasma torus. By observing Io with the ALMA telescope array, astronomers have now discovered that the moon's atmosphere is missing up to 99% of its original, lighter sulfur-32 isotopes. Isotopic sorting explains why. The lighter sulfur-32 rises to the top of the atmosphere, where Jupiter's magnetic field easily strips it away, leaving the heavier sulfur-34 trapped below. This missing sulfur provides a forensic record, allowing researchers to calculate exactly how much matter has been lost over the moon's history. Based on the absence of that lighter sulfur, scientists concluded that this atmospheric stripping process has been active since the solar system first formed. Incredibly, Io's volcanoes have been erupting and fueling this entire electrical machine for over 4.5 billion years. Io survives this process only because the gravity of its sister moons, Europa and Ganymede, is constantly melting and reforming the moon's interior. This reveals the solar system as an integrated machine, where the heat of a molten moon and the auroras of a giant planet are parts of a single, ancient electrical circuit.